Hi, this is Mrs. Boykin. We're going to continue on in our factoring chapter, and we're going to introduce solving by factoring. I would like you to please copy these notes into your notes and bring them to class, and by doing so you'll receive credit. First of all, we talked about what a factor is, and factors are terms that when multiplied equal the original problem. So for example, if we're going to talk about the numbers that are factors of 30, we can say 1 times 30, 2 times 15, 3 times 10, and lastly 5 times 6, because either of these, when multiplied, will get our original number 30. Polynomials are a little different. Unlike factors of numbers where there's multiple different options we can choose, there's only going to be one correct solution, that when you multiply the two binomials together, they will equal the original polynomial. So let's take a look at when factoring, we're going to take it one step further and solve, and that's the easy part. So here are our two problems, or our two binomials, b minus 3 and b plus 5. So if I am going to set each of these equal to 0 so they can be solved. And we're solving it just like an Algebra 1 problem. So if we add 3 to both sides, my first solution is v equals 3. Subtracting 5 from both sides for our second problem, we get v equals a negative 5. So when we solve, we get v equals 3 or v equals a negative 5. Let's take a look at the next page. The zero product rule tells us that if we have something, call it a, and we multiply it by b, and that result equals 0, then either a equals 0 or b equals 0. And sometimes maybe both a and b both equal 0. So in order to solve any polynomial, your equation must be set equal to 0 before you begin. And that brings us to the next part. When we're solving, we get solutions, or some of these other words that also mean the same thing. I call it the Red Sox. Not that I'm a Red Sox fan, because after all, I am from New York, so I guess that makes me a Yankees fan. But here's what it stands for. First of all, the R in Red Sox stands for the word roots. Sometimes you're going to hear solutions referred to as the roots. Another one is solution, and we've already talked about that. Another word that means the same thing, I think of the O in Red Sox as zero. So it's talking about the zeros of the equation. And finally, X. X stands for the x-intercepts. So just be careful, any of the directions that say find the roots, find the solutions, find the zeros, or find the x-intercepts, they're all referring to the exact same thing. Now let's take a look at another problem that this time we need to factor it. Sometimes you're going to see the problems written in this manner, where they're already going to be set up equal to 0, or they may say f of x equals x squared plus 3x. Again, the same problem. F of x is just a fancy way of saying y. It means the function evaluated for x. So here we go. We're going to talk about solving this. We're going to start out by factoring. Now this problem here, we have a greatest common factor, x. And when we factor out the x, the result is, when we divide, x plus 3. We're setting that equal to 0. So remember the zero product rule. Our first term, it's not a binomial, it's just x equals 0. There's nothing to solve, so that is one of my solutions. Or x plus 3 equals 0. If I subtract 3 from both sides, I get x equals a negative 3. So my two solutions are x equals 0 or x equals a negative 3. Let's take a look at the next problem. This problem now requires factoring, and just like our last section, we always start out with seeing if there's a greatest common factor. I'm going to go ahead and work this problem. Why don't you pause it now, and then when you factored it, you can compare your results to me, and then we'll proceed. So go ahead and pause it now. Okay, here we go. I've gone ahead and factored this for you if you want to follow my work. Found out there's the greatest common factor. I did the field goal method, as you know, and we're looking at the multiplication of 1 times -3, and it's going to add up to my center term. I then split my center term into 2 parts and factored the rest. Again, if you need help on factoring, please go back to one of my previous videos. So the factorization is this entire thing on the bottom, and we're going to break it down piece by piece, again setting each of our factors equal to 0. Let's start with our first one. 5 equals 0. Well, that doesn't make any sense. So there's not going to be any solution that's going to come from this. So we're going to just ignore that. Our second factor, I should say, is x minus 1. We're going to independently set that equal to 0, adding 1 to both sides, and we get x equals positive 1. My last factor is this x plus 3. Oh, meant to do that in red. X plus 3 equals 0. Again, solving, we get x equals a -3. So my two solutions, my roots, my solutions, my 0, my x-intercepts for this problem is x equals the positive 1 or x equals a -3. And those are my two solutions. If they were written in set notation, you would see 1, -3. Let's take a look at the next problem. Once again, I'm going to go ahead and pause the video. You go ahead and factor it, and you can compare your answers to me. This time I'm not going to be showing my work, I'm just going to be showing you the final solution. Let's pause it now. Okay, I've fully factored this. As you probably found out, there was a greatest common factor of 2. After that, when I factored it out, I get 2 times n plus 2 times n plus 7 equals 0. So if we're going to find the roots, the solutions, the zeros, or the x-intercepts, we would independently set each piece equal to 0. Just like our last problem, 2 equals 0, that doesn't make any sense, so we're going to just ignore that. My n plus 2 equals 0. I'm going to solve for n. I'm going to get n equals a -2. And my last factor, n plus 7, set that equal independently to 0. Subtracting 7, I get n equals a -7. So my two solutions, my two roots, my two zeros, my two x-intercepts are n equals a -2 or n equals a -7. Let's go to our next problem. This one here, we have a little bit of prep work to do before we can begin. I hope you notice this isn't set equal to 0, and we've not seen one like this before. But that's okay. Using our Algebra 2 skills, we're going to rewrite this equation. We're going to get all our variable terms and constants over on the left-hand side so that the right-hand side will equal 0. So let's begin. We're going to start out by moving this -3x squared to the other side. So I'm going to add 3x squared to both sides. Combining like terms, I get 3x squared, and also I notice that my constant is before my x term. And in standard form, we always talked about going from the highest exponent down to the smallest exponent. -3x squared and a positive 3x squared cancels out equals 0, but don't forget on the other side we have that -3x. My next step is to get rid of the -3x over there, and so that it equals 0. So we're going to add 3x to both sides. And again, we have to combine like terms, so that's why I'm writing it underneath. And I have 3x squared plus 8x minus 3 equals 0. I'm now all set to factor this. And so I'm going to pause the tape while you go ahead and factor it, and we'll compare our results. Okay, how'd you do? When I factored, I got 3x minus 1 times x plus 3. So we're going to set the first binomial equal to 0, and we can solve it. We're going to add 1 to both sides. And now we're going to divide by 3. So for this problem, I get x equals 1/3. Let's go ahead and do my second binomial, the x plus 3, set it equal to 0. Subtracting 3 from both sides, I get x equals a -3. So here is one of my roots, and here is my second root, my solution, my 0, my x-intercept. One last problem to do. I'll do the prep work with you. So we're going to start out by getting the variable term over to the other side. So we're going to add 3n squared. Comes out to be, and we always like this leading term to be positive anyway, so it works out nice. I'm going to take this -17n and bring it down next so that my terms are in order, and my constant comes last, +25, and this equals 0, and we can't forget that we have the +5 over here. Okay, let's get rid of the 5, because remember we need to get this equal to 0. So we have 3n squared minus 17n plus 20 equals 0. All right, you're going to factor, and I'm going to pause this, and we're going to come back and check the answer together. Okay, how'd you do? n plus 4 times 3n minus 5. Let's go ahead and solve. n plus 4 equals 0. n equals a -4. 3n minus 5 equals 0. We're going to add 5. Dividing by 3. n equals 5/3. So those are my two solutions, and you're all set. Hopefully you can work the rest of your worksheet without any problem. If you need any help, come into CAB Morning or review the videos on factoring if that's where you're having trouble. Talk to you soon.